All right, so the goal of this video is to talk about generating data in Excel that you can use for a contour plot. And let me bring up an Excel sheet. So here I have, well, in this spreadsheet, you could see that my goal is to try and learn about the theoretical acceleration for some experiment given by some crazy formula that I'm wiggling around here, this A subscript TH for A theory. Okay, so what I'm going to do is I'm going to, oh, and I have some constants here. So you can see that M1 and G are constants. And just in case, I'm going to make this hella big, just so, right? Why not make it as big as possible? That's pretty good. All right. So in this case, the first thing I'm going to do is label this constant in the name box. So we'll go M underscore one. You could pick different names. And then this one, I'm going to again, I click in the name box and I'm going to type the letter G and then I hit enter. Okay. So now when I click on this, you'll notice that it has a name here. And you can see if I click some other cell and I type the name M underscore one, aha, it knows that's a constant and I don't have to use dollar signs. I could reference that cell as a constant using dollar sign I, dollar sign two, and notice that will also work. And what happens is when I fill cells right, or down, it will keep using that same cell. The same. All right. So that's enough on the constants, but that's going to come back in just a minute. So now, and I guess I should mention here, this mass right here. Oh, I should have used a different color. Whatever. This is M2, and this angle right here, that's theta. So in the theoretical equation, you can see it references all of these different things, M1, M2, but also theta. Now, the tricky part here, M1 and G are constants. That's going to be pretty easy. We'll reference these two cells up here. But now when we're talking about M2, we could see that we have a range of values of M2 we want to use and a range of angles we'd like to use. Now, I'm going to get rid of the last few of those. All right. So, yeah, let's leave it at that. Okay. So how are we going to do this? Let's start in this cell. The first thing I want to type, I want to have Excel do the calculation. First thing, type equals. Equals. Now I'm going to just follow the formula that I have right here. I'm going to follow that formula as I type. Because I listed the constants, I could type G times, and then I could see I've got something in the numerator divided by something in the denominator. And then what I oftentimes do is I'll go up into this function bar up here to do my editing because it's a little easier to see up top because what happens is as you start typing, things get covered up down underneath. So let's go into this function bar if I can get there. And the first thing is M2. So I'm going to click on the first value of M2 or type C5. And then I'm going to subtract M1. That's a constant. M1, whoa, times sine, and that's a function. Now we have to be, oh, shoot. Now we have to be extra careful. The sine function uses radians. So I'm going to type another function in here, radians. And so the idea here, you can see that I'm using some space to make this easier to see. C5, that's the hanging mass. M1, that's the constant. G, that was a constant too. Maybe I'll put some space in there so you can see a little better. And then I'm doing this part of the function. Whoops. I want to do the M1 sine theta. So, and I have to use radians of, let's see, cell B6 looks correct. All right. And now in the basement, I need M2 plus M1. Now, this one is probably easy enough. You could tell it should be zero. Okay. If you have no hanging mass and no angle, both of these two terms in the top, this term and this term, go to zero. So that's fine. All right. So, and actually, I'm going to clear out my annotations now. Uh, Let me do that real quick. Okay. And so now watch what happens if I fill this down and to the right. I guess I should have said to the right and down. In particular, let's look at one of these random numbers over here. We can see that it is referencing the constants correctly, but it's not cell H9. And I mean, I don't know if you could see this, but it's looking at this cell and that cell. When I get rid of my annotations, take a look here. Oops. Notice there's a small border around some of these cells, and we see that it's not referencing the correct cells. It's no longer using the angles over here in column B or the hanging masses in row 5. So there's an issue we have. We need to fix it. And it has to do with the dollar sign now. We can see that knowing the dollar sign is going to help. And let me get rid of those annotations. All right. Oh, geez. All right. There we go. So let's delete all this because it's wrong and try again. Okay, so hopefully you could see the function here, and I can tell that I need to do something with parameters C5, which is the hanging mass, cell C5 right there, and also B6, which is the angle. Think, as I fill down, as I go to the right, we do want the hanging mass to change. So we want the column to change. We want it to be C, D, E, F, G, and H. So what we don't want the row to change. So rather than doing $C, $5, which locks both of them, I'm going to do just $sign on the 5. And I'm going to do that in both places where it appears. So what that should do is it should allow the column to change, which we need, but not the row. Okay, take a second to think. What do I need to do on the angle? Do I want to lock the row or the column for that one? I want to lock the column. To lock the column, do I put a $sign in front of the B or in front of the 6? I'm going to put it in front of the B. So now this should work. I'm going to go ahead and hit enter, fill to the right, and fill down. And let's click on a random cell. And notice we're still using the correct mass and angle for this cell. We could click another one and see. And so, oh, that one's kind of hard to read. Again, sometimes, let me do this. I'm going to actually just stretch this way out just so it's a little bit easier to see. Now the equation doesn't cover up the cells that we're looking at. And you can see this works for a wide range. All right, looking good. And that's basically it. Let's go and stop that's how you generate the data. In the next video, I'll show you how to make